Sure. I'll add you again in a minute.
Sure.
Hi guys, can you hear me? I see 3 people have joined in already. Okay, if you can hear me, just say hi or anything in the YouTube chat. Let's wait for a few more folks to joining in. Hey, hi Rahul. Wow. Hi Ravinder. Oh, sorry. Hi Randhir. Okay. Okay, we are waiting for a few more minutes before we start. Okay. Let other people join in. Rahul in Ahmedabad or in Pune right now? Thanks, Randhir, for letting me know. Currently working from home. Arre. Good to hear that. Let's wait for a few more folks. Okay. So we'll wait for a few more minutes. I think a few more folks should join in. So, before others are joining in, just to, give everybody a bit of background, it is supposed to be today. We were planning to have an event in Ahmedabad itself, as Serverless Days Ahmedabad. And because of COVID and everything, we had to, shift our event. So it's been postponed till December now. Okay. And now, to keep on, going back to serverless and the things that are happening, around the world in serverless as a architecture. Okay, so we've decided that uh, we are going to stream every Saturday for an hour. Okay, and I'm going to bring all the different folks around the world, okay, who could give us the knowledge on serverless. And I'm glad I'm starting this session with Vishal. Okay. Uh, few months back, we don't know each other and we haven't got a chance to speak that much, but I knew Fission for some time. Okay. Uh, I follow CNCF very closely, and I used to track what are the new projects coming up. Typically, I follow Serverless landscape, which is there in CNCF as well. It's part of CNCF itself, and there are other projects and other frameworks that I keep on seeing and utilizing. Okay, I've been working with folks at Tundra. Our previous session was on serverless observability with Tundra. Okay, and I happened to connect with Vishal, and let's have I thought, why don't we start our serverless marathon? Okay, till December we are going to do this. All the folks who are either working on serverless or who's been in part of creating products which are on serverless. We thought to bring all that knowledge to this community. And with that in mindset, I've started this marathon in which every Saturday we'll spend an hour and talking about different things, different aspects in serverless. Okay, so I've been working a lot on AWS and Lambdas and different products which are available part of AWS, which we can utilize to create end-to-end serverless stack. Okay. Now there were questions coming back and forth that what to do, in a case where we are having an on-premise setup, and we want to leverage the basic concepts of serverless. Serverless is what is basically, see, it's a terminology in which you don't augment a service 24/7. Okay, you keep it available as and when somebody needs it. As and when you get an event for it, you invoke that, you get that service served, and then that particular service goes away. That's the basic principle of serverless infrastructure, right? So there were questions coming back and forth that fine, we are working on AWS, we are working on Azure, we are working on Google. All of them has their own serverless frameworks in which we can deploy different native services for cloud, for compute, right, to get certain business functions served. Now, how do I do it without having vendor dependency or without having my own setup in a public cloud, right? That's where I think products like Fission can help us, in which you can build your whole functions on top of your existing Kubernetes clusters and get different different business functions served using the same fundamental mindset which is there with serverless. Okay, and with that in mindset, hi Cavalier, hi Rahul, hi Archana. Okay, good to see everybody. Fine. So with that in mindset, I thought to invite Vishal and give us, a 101, a very simple, very simple and very basic understanding of what Fission does and what are the different aspects, of Fission. Why should we implement it, and what are the different use cases that we could leverage using this, new product which is available part of CNCF. So I'll add Vishal as well into the stream now. Hi, Vishal.
Hey, thank you. Hey, everyone.
Thanks a lot for joining and thanks a lot for the time. Honestly, with all these things going around and in the position which you are, I know it's difficult to get the time out.
No, pleasure is mine. Yeah, I think it's been a while that we haven't done any Fission sessions in recent times, so I thought it's a good opportunity.
No, I'm also excited to learn a lot about Fission today. So, as I mentioned, I've never got in touch with you, but I knew Fission for quite some time now. As I mentioned, I keep on reading different products which are there, and which basically comes in CNCF landscape. So that's how I came across Fission, and there were people, in our, we part of serverless days global. They had this Slack channel where different serverless people have came together, and like it's more related to the community, but we do a lot of discussion around different topics on serverless. If I'm doing something with AWS API, and that's when I heard about Fission first. That somebody wanted to understand that anybody used Fission, and somebody wanted to utilize, and that's why I thought, okay, fine, that's something new for me. Let me dig into it, and it happened that I got to you through Ganesh.
Yes.
Cool. So, Vishal, why don't you introduce yourself for the community? I'm sure a lot of these folks would want to understand who you are and what you've been doing, and then what is the thought process behind Fission, and we'll start from there.
Sure. So without going into deck, I'll just quickly introduce myself. My name is Vishal. I'm CTO and founder at Infra Technologies. We as a company focus more or less, on the cloud-native technologies and the whole space around that. So personally, I think my journey with DevOps started, I think, about 5-6 years into my career. I was more of a Java developer before that. And then I, got more interested in the DevOps, CI/CD areas. Chef Puppet happened. Then Docker happened, and then Kubernetes happened. So it's been a very exciting journey over the last, I would say, 7-8 years. And you see how things evolve. Like I tell a lot of people that I thought Mesos will be, the orchestrator, but as you can see today, Kubernetes has won the race, right? So it's a very exciting times to be in. I believe serverless and Fission definitely are an exciting piece of technology as well. So Fission was started, by an original author called Som. I joined the project somewhere, probably a year down the lane, and since then I have been contributing constantly, since then. And of course, Fission is a serverless, framework on top of Kubernetes. So you can technically run your microservices on one side and Fission on the same cluster, and still get the flexibility of Lambda-like experience from a developer's point of view, definitely.
Good to hear that. So, Vishal, I'll ask you to continue with your session from now onwards. I'll go on mute, and session is all yours.
Sounds good.
Just share your screen. I'll put it up on the this thing to go live.
Sure, give me 1 second.
Okay, just give it a minute. I've put it up on the live, but there is a lag of 10-20 seconds. So, guys, all of you who are watching, just let us know once you are able to see Vishal's screen, and then we can start with this session. And one more thing is that, guys, whatever questions that you have, keep those questions, during the session. Keep on writing them, in the chat. I'll go through those questions, and we'll take up those questions at the, end of our session. Okay, now, Vishal, people can see your screen. I'm going off. Session is all yours.
Cool. Thanks, Ankit. All right. So we will talk about using Fission for fast and simple functions on Kubernetes. As I did introduce myself very quickly, my name is Vishal Biani. I'm CTO and founder at Untitled Technologies. I typically keep dabbling with technologies around Kubernetes, serverless, and the general cloud-native landscape. We also organize Kubernetes Pune meetup, which we have been organizing now virtually since the COVID-19 outbreak. So please feel free to join us. We do it almost once a month on a Saturday morning, typically 10 o'clock, 10:30 a.m. Usually. All right, so let's get started with Fission. So as you can see, we're going to talk about a few functions. So that's why I named it table of functions. It's kind of metaphor since we're talking about functions. It's a table of functions. So we'll start with a very brief introduction to what Fission is. And then what we will do is we'll cover one concept at a time, what an environment is, what a package is, what a function is, and then how to trigger those things, from an outside world or from an event kind of things. And as we go through these concepts, we will also introduce some services which Fission uses internally to manage these things. So it's going to be a very user focused, at the same time giving you an overview of how internally Fission works in a way. At a very high level, just scratching the surface, not going into too many details there. Then we'll create a function with spec, without spec, and then we have a larger demo of 6 odd functions working together with a few databases, together. And then we'll kind of wrap up with a Q&A and any other open items that discuss together. So Fission is a framework to develop functions on top of Kubernetes. So think of it like Lambda, but for your Kubernetes cluster or any Kubernetes cluster for that sake. You can write code and deploy functions. You don't have to worry about building that into a Docker image or understanding how Kubernetes works. So in a way, it abstracts Docker and Kubernetes for you. Having said that, you're always welcome to go and check out the underlying details. But the idea is that keep it simple for the end user. And it has a concept of warm pool. And by that, it can promise a cold start of 100 milliseconds. What I mean by that is the whole idea of serverless or a function as a service platform is to keep your compute minimum when there is no request coming in. So in case of idle. So Fission achieves that using a warm pool where it keeps a very small pool active and actually scales out when requests start coming in, and then again scales back to idle compute when there are no requests coming in. It supports a bunch of integrations as an event source, and it does a bunch of other things around tolerations, volume, security context, which we'll again walk through in detail in the coming slides. While we are at it, I would really be happy if you would go and star the Fission project on GitHub. You can also find other details on the docs website, on the blogs website, and on the Fission.io. So please feel free to visit those and check out the project. Cool. Let's get started with some Fission concepts. We'll basically build one by one and on top of the previous one in a very sequential manner. So the very first thing I want to talk about is an environment. So environment in Fission is nothing but a package of the OS or runtime and the dependencies that you need, minimum number of dependencies that you need to support for that runtime. So if I were to take an example, if you talk about Node.js environment, the base runtime that we use is a Node.js Alpine image, and then we have a few dependencies which are bundled in along with this runtime. For example, Express, the request dependency, or request promise native. Now, if I take a similar example of Go environment, it looks starkly different, and I'll tell you why. So in case of Go, we have the Ubuntu 18.04 as the base environment, and then we have a simple Go server running in the environment, but we don't have any dependency. And you must be wondering why. Because in case of Go, since it's a compiled language and it produces a single binary that you can technically execute, it doesn't need to have any specific dependency in the environment built in. So that's why you don't see any dependency here. And that's the difference I wanted to kind of demonstrate and just bring out by comparing these two environments. So at a conceptual level, it's just a simple OS runtime and then a few dependencies that you absolutely need for that language or for that runtime environment. Now, once we have environment, that is good. But what we want to do with that is add some code, right? Some custom code which you can execute and run. So that's where the concept of package comes in. So a package is an abstraction for your code. That code could be either source code or it could be a binary. So in case you upload source code, and if it's a compiled language, you can actually compile from source code into binary inside Fission. We'll talk about that in a moment. And if it is something you want to compile locally and simply upload the binary, you can do that as well. But it's just the same mechanism with two different kind of sub options, if you want to call it that way, right? And you can also add additional dependencies. For example, let's say you're writing Java code or Node.js code, and your code actually uses a new dependency. You can define those as part of your user code as well. So that all is encapsulated into a concept called package. Now, what Fission can do is take your package, and if it is a source code, it can compile that into a binary using a builder service, which is built inside the Fission. And if it is a binary that you're already providing, it's simply going to put it into a storage service. Now, this yellow blocks that I'm introducing one by one on the right-hand side, the rightmost column of the diagram, are actually Fission services. So I'm explaining, what each service is doing while we are also talking about Fission concepts like environment, package, and functions. So once you create a package, it references an environment, of course, and it references a builder. So builder is what actually builds the service or the code into a binary and puts into a storage service. Now, this storage service can be backed by two things. It can be backed by a persistent volume, or it can be backed by a S3 compatible object store. And that's just matter of choice. Some people want to store the code for a Fission function into volume, but some people might say I just want to store it into an S3 bucket, basically, right? Cool. So now we have the base environment. We have some custom code that we have written, but what do we do with that next, right? So that's where the concept of function comes in picture. Now, function is an abstraction which basically takes your environment reference and your package and adds some additional runtime configurations. For example, how much CPU or memory to allocate to that function, or should it time out in X seconds or Y seconds, or the scaling parameters. How fast it should scale, on what parameter it should scale. And then also it allows you to add things like secrets and config maps, which are Kubernetes constructs. But at a very basic level, secret is something like a certificate or a password for a system that you want to connect to. Or config map is nothing but a simple configuration, key value pairs or properties files that you will add to a function. So that constitutes a function. Now, a function, once you have created, can be executed in a couple of different ways, and that's where we will talk about execution strategies. So execution strategies will define how your function actually behaves at runtime, and those characteristics will determine on what kind of use cases you will use a certain kind of function. So let's go and dive into the execution strategies. So Fission right now has two execution strategies. We'll talk about the first one first. So PoolManager is one of the execution strategies. So what it does is when you create a function of type PoolManager, it creates environment pods and not function pods. So I'll just briefly clarify what that means, right? So all it does is it creates a pod which has only the OS runtime and the dependencies and keeps a pod ready. It doesn't still have the user function or the user code. And the user code is actually executed or loaded rather easily. And this again is handled by a service called as executor service. Now what happens is you have a warm set of pods ready to be used. Now as soon as the user request comes in, what Fission does is takes one pod from that pool outside, and that process is called specialization, and then it grabs the user code from the storage service and drops into environment. So this is like dynamic loading. And how this loading happens is actually depending on your underlying runtime. For example, the loading of code for Node.js might be different. The loading of code for JVM might be different. But fundamentally, it's the same process, the same API contract, right? And once it has loaded the code into the environment, it actually executes that code and then returns the response. So what we are doing here is, on the fly, as the user request comes in, go and get one environment pod from the pool, a small pool, drop the code into it, and then execute it and then return. So there is, of course, a small penalty of a latency. And we have tried to keep that latency less than 100 milliseconds. So it's hardly noticeable for the end user. But you're basically on the fly loading the code and executing that. And there are pros and cons of doing this versus doing something else, but we'll just compare and contrast that in a couple of slides. So this is one way of loading code when a function is executed, and it is called PoolManager. Let's go to the next one. Yeah, one thing I forgot to mention about the PoolManager is, now let's say the user request came, we execute the request, we return the response. Now for next 3 or 4 minutes, that timeout is configurable, no more user requests are coming in. This pod, which was specialized with the code, is actually cleaned up. And if more requests are coming in, it will stay beyond that duration. So if within 3 minutes, one more request comes in, it will stay for 3 more minutes after that request is executed. But if the requests don't come in anymore, it will be cleaned up, basically. And then you're back to the pool size that you had initially. Now going to new deploy as a different strategy of executing code, right? Now imagine if we try to do this PoolManager thing for a Java code base, which is fairly large, has a lot of code dependency on it. The specialization might take a few seconds and not 100 milliseconds, because this is something purely depending on the underlying runtime. We can't really control how fast a class can load in Java, right? And in that case, maybe it's not a great strategy, because you don't want your users to wait for like 7-8 seconds if they are calling something in a real-time interface, right? And that's where we have the second execution strategy, which is new deploy. In this case, what happens is, as soon as you create a function, it takes the environment pod and drops the code right away into it as it is initializing. And then this completely specialized pod is ready to serve traffic. So there's no lazy loading. It is happening as soon as you initialize. And as soon as the request comes in, it is served immediately, and there is no latency. There is no additional latency, basically. So this is great, especially for functions which you want to call in real time, and for languages which are slightly slow to load into runtime, right? Whereas if you talk about PoolManager, it is probably a great choice if you're talking about event-driven, use cases where a user is not waiting for the response to come in, and it's more like an asynchronous event which user is not, going to get affected on. Now, if I have to quickly compare between these two execution strategies, right? So if you choose a new deploy executor and if you keep the minimum scale as 0, it's going to take a while for the new part to start, load the code, and then actually execute the event. So the latency is high, but the cost is very low. You're not maintaining any pod, any pool over there. But if you use new deploy at a scale greater than 0, that means you keep one pod always running. Your latency is super low. It's real time. It's as good as running a microservice, not running a function really. The idle cost is medium, meaning you're saying I'm going to maintain one pod always. If the more load comes in, I'm going to scale from 1 to 2 to 3 to 4 or whatever. But definitely you need to keep one pod always running. Now, if you talk about PoolManager, what we are doing here is we are maintaining almost 0 pods with code inside them, right? So the latency is low, but there is of course that 100 milliseconds, figure, and the cost is also low. So what you can do is, let's say I have 100 Node.js functions, for example. What I do is I keep a pool of 5 Node.js environment pods running. And as a request comes for an individual function, I take one pod out of that pool, load the function, execute it, return that. And that way, I don't have to maintain 100 pods running for 100 functions, right? So we are trying to say, no matter how many number of functions you have, all you need is the runtime that you need to maintain warm, and then load the code on the fly. So again, there's a little bit of nuance there, depends on the use case, but at a high level, this is what the comparison looks like. Now, going back to our previous environment, previous diagram, sorry. I have the environment, I have the package, I've created the function. I can create either PoolManager or new deploy, but I want to call it, right? So there are a couple of ways to call it. One is the HTTP trigger, and for that we have router service. So you expose the function outside of your cluster using router service, or you can keep it internal to your cluster, assuming that somebody else is calling that function. So that is one way to expose the function. The second way to call a function is time trigger. A lot of times you want to run a specific function at, let's say, every 5 minutes, for example. So let's say you're checking weather, periodically. You want to call it every 5 minutes, check the weather, return the response, and then die, so to speak, right? So that is where you'll use time trigger. The third way to invoke functions is based on message queues. So let's say a message arrives in a queue like Kafka or a NAT streaming or Azure, queue service, queue storage trigger, and you want to execute a function based on a message arriving, right? Very standard use case. Think of like Amazon, right? When you place an order, the order goes into almost like a message queue kind of, infrastructure, right? From there, it might be delivered to a warehouse. You don't need to do it almost immediately, but of course, within some reasonable time, you will want to execute that, right? So you'll drop into a message queue, and then there'll be a worker function or a worker thread which will pick up that message, process it, and put it into next set of actions, basically, right? So that's where you can use message queue kind of trigger. So these are like 3 broad kinds of trigger, and we'll again go into slightly more details in some of these areas. So as you can see the whole picture, at a very basic minimum level, for a function user, you need to understand environment package function and one of the triggers that you're going to use. And as a developer, these are the minimal pieces that you need to understand if you want to contribute to Fission, if you want to develop a feature, fix a bug in Fission, right? Cool. Now, I spoke about these 3 triggers that are present today in terms of message queue, the NATS, Kafka, and Azure queue service. But as we are speaking, there is a new integration being developed, and we are using an open source project called KEDA. So KEDA is an open source project from Microsoft. It allows you to scale pods based on certain events, and it does it, in a very minimal footprint manner. And once we develop this integration, we'll have a whole new suite of integrations with which Fission can integrate. right from PostgreSQL to NATS to Amazon SQS to RabbitMQ, Prometheus, bunch of services from Microsoft, Google pops up, Redis, Amazon Kinesis, Kafka, whatnot, right? And I just yesterday gave a talk on this. How do you use KEDA along with virtual kubelet, not with Fission? And so you can understand more about KEDA by visiting this talk. It starts about 3 hours into that video, and there'll be individual video that will come out in a couple of days. And I'll share that on my Twitter as well. So this feature is landing somewhere in July. And once that lands, we'll open a bunch of new integrations in Fission, which will be very exciting, actually. Cool. I think enough of talk. Let's do some hands-on, demo and see, get a taste of Fission. Okay. Cool. So what I'm going to do is, so let me share my next slide that will show the, yeah. So first thing we are going to do is create an environment of Node.js type using image Fission node environment. Right? As you can see, the node has been created. There is a typo there, so I'll delete that and create once more.
Vishal, can you just increase the font size so that
yeah, good.
you can see it better?
Is that better, or should I make it even bigger?
I think this is okay.
Great. Okay. As you can see, so now we have one environment. There is a typo, but ignore that for now. And just to show you the background as to what is happening in the, as soon as I create environment, and since I didn't specify any type, you will see the 3 pods have been created of node HS, Node.js ideally should have been called, type. Now, what we'll do is take a piece of code and create that function. Now, in ideal world, I would have created a package separately and then created the function separately. But since we're using a single simple file, I can actually do like a shorthand, create package and function in the same step. And I'll have to correct the name, of course. As you can see on this screen, it created a package first, and then it created a function. And let's see if we can list the function. Right, so we see that there. Since this is a PoolManager function, some of the parameters are not applicable, but we can see the function, ready. Now let's execute this function. And on the other window, what I'll do is I'll show you what happens, to the specialization part. So there are only 3 pods running right now, right? And I'm going to do Fission fn test. As soon as I do that, there is one pod getting created, which is basically specialization. The code gets dropped, and I get the response almost immediately, right? Let's time it a little bit. So I should have already done the time in the first place also, but you can see in the 0.05 seconds, it has returned, and it's pretty like instantaneous. You can't really feel that specialization is happening in the background. But of course, now since we are calling the same function over and over, the specialization is not happening every time. It was just the first time, as you can also see at the bottom. Cool. We'll do the time again once we do another function creation in the next few moments. So as you can see, it has created the function. We tested it already. Now, this is great if you're doing, one-off function creation on the CLI. We can remember all the commands and stuff, but maybe not very scalable if you're doing like a proper application development for functions, right? And that's where we have a thing called specs. Now, specs are nothing but a way to define function in a very similar manner as you do in Kubernetes world, which is by using an YAML. So it is better if you want to use it for a proper application with better source control for CI/CD. And the best part is once you created the function using Fission spec, you can actually do kubectl apply, and it will be applied. So a lot of times what might happen is you might have a few functions, but you might also have a database or something else that is Kubernetes native. Instead of using Fission apply, you can also do kubectl apply, and everything will get applied basically. So let's try this out. So for this, what I'm going to use is I'm going to use a already created spec here. I'm going to show you how it works. So we have environment spec in which we define the environment, we define the image, and we define a bunch of parameters. And we are also passing a environment variable here. And the second thing we are doing is we are defining the package. So the package requires archive upload spec, and then there is function definition, which says PoolManager with bunch of other configurations like which environment to point to and stuff like that, right? And we'll create this. Right. So I'm in the same directory. I'm going to do Fission spec validate. It tells me I'm going to create one function, one environment, and one package, right? And nothing else. And there's one archive upload spec, of course. So I'm in the same directory where I showed you the spec. And the way it is structured is we have the spec directory, which has the actual spec of the function. And then we have the hello directory, which has the actual code, including the package.json and the hello.js file, right? So let you again show the actual code. So hello.js is importing a new module, as you can see, the process module. And it is getting an environment variable from the environment, and it is going to simply print that variable. And in the package JSON, you can see we are importing one additional dependency. Okay, it's not mentioned here. I don't know. Okay, just not actually probably using any other dependency. It's a built-in dependency in process, I believe. Now, I have validated. I'm going to do Fission spec apply, and validation successful. It runs validation again, and it creates a function called hello. Now, this is again a PoolManager function. Let's list it out. Yeah, the type is PoolManager, even for this one. And it has created a pool for that. Now, technically, I got to use the same pool that I had before, but since I have just a different directory, I'm creating that. Now, let's time this, and this is the first time we are calling this function for this pool. As you can see, the first time takes a little while as compared to probably second or third time. Okay, that's weird. Shouldn't have failed. Something is wrong there. Let me test it once more and see if it works. I'm just checking if the cluster is okay. Okay, there is some problem there. I don't know what that is. I did test it just before this call and it was okay, but for some reason it is failing now. Let me see if we can debug that live without taking too much time. Okay. As you can see here, the package build status is still not ready. So now let's do one thing. Let's list the package. All right. So as you can see, for the second function that we created, the build status for the package failed. So the build actually happened inside the cluster. Now what I can do is here is I can do a rebuild. And this is an open bug. We are still fixing that in this release. I'll just talk about that in a minute. But now we can see that it has kicked off the build again. So what happens is the first time you kick off a build, the builder pod, which is in a different namespace, takes a while to bring up. And if that takes a while to bring up, the builder kind of gives up. And this is what has happened in this case. Now it has succeeded, as you can see, once I rebuilt it. And now once we test it again, it should work like before. Right. So we got the response, right? And as you can see from the time first time it takes probably more. Second time it's a little faster than the before. Cool. So that was a simple demonstration of the spec, for a function in Fission. Right. Going back to the slides. Now, one of the other features that I'm super, I find very useful, and a lot of people also find it useful, is called a spot spec. Now, I'm not going to go into too much details on the pod spec here, but this enables a whole bunch of new use cases. It is kind of recent feature, I would say, launched like 3-4 months ago. It allows you to do taints and tolerations. So by using taints and toleration, what you can do is you can say on a certain node you can schedule function, or a certain node not schedule the function, right? For example, if you're doing, for example, machine learning kind of workloads, you want to schedule the function on a node which has GPU attached to it, right? Otherwise it will fail, otherwise it will run very slowly. So you can use taints and toleration. So you can apply taint on the node and then toleration on the function to say that a function for machine learning workloads should go only on nodes with GPU attached. The second thing it allows is, among other things, volume mounting. There are a lot of use cases where a huge amount of data needs to be processed by a function, and it is not feasible that you load that function data using like an object storage or anything else. So the best idea is to attach the volume to a function, do some transformation, and then write it back to the same volume. And then once function has executed finished, you can detach the volume and continue further. It also allows you to do init containers and sidecars. Init containers are super useful if you want to bootstrap your function with something. For example, I want to fetch a few files from my S3 bucket, drop them into a volume, attach that volume to my actual function, and then function can use that volume which dropped data from S3 bucket to process something. Init containers are a great way to do that. You can also run sidecars. Let's assume I have a function which needs a temporary cache, for some in between, transaction or interaction. You can actually attach a Redis sidecar or a memcached sidecar along with the function and execute the function, use that cache in between, and eventually put the result, into some persistent store. You can also do custom scheduling. This is probably very similar to what we talked about taints and tolerations, where you can decide to use a custom scheduler built into Kubernetes or a custom scheduler that you yourself write, basically. You can also do security context, node selection, and readiness gates. Again, all these things are discussed in detail in this blog on the Fission blog. So please feel free to read that or ask questions on the Slack or on Fission. Cool. Now, all these things are there in Fission, but I'm excited about what is coming next. So based on some of the users' feedback that are using Fission in various environments, dev or production, and based on the community, we have found that one of the many frequently asked features is debug breakpoint. So for example, when we ran into this issue in the function that we were debugging, ideally what would have been super nice is I can attach a debug breakpoint in the code in my IDE and then actually debug it live, as to what went wrong, right? So instead of having to, again, guesswork what went wrong and then trying it again, would have been super useful if we had a way to add a debug breakpoint into IDE and then step by step look at what happened, what variable is having what value and stuff like that. The second feature, which has been a long-standing request from users as well, also has been our roadmap for a while. Instead of you giving a piece of code and building that and then loading that into a function, what if I can simply say I want to run a Docker container as a function? So the part of building the code and actually compiling and everything I can take care of. I just want to give it a container, and Fission should manage that container, right? So this is one of the really exciting features that will be coming in the next few months. We also had a Java environment, I would say almost for now year and a half. But when we built out Java environment, Java 8 is what we used because that was kind of the commonly used JDK at that time. But we are now coming up with new JDK environments, 11, 13, and 14 of Java. Next, we are also looking at something called as in-browser development, or I call it in-cluster development. So with the advances, of, for example, GitHub code spaces or Gitpod, you can technically now develop your code inside a browser in a full-blown IDE in the browser, and then attach a cluster in the backend so that your actual development happens, almost in the cloud, so to speak. So we have an open PR for that for Gitpod, but as soon as GitHub code spaces is available publicly, I'm thinking of that becoming the target for this. And then a lot of people want to use Fission as a multi-tenant system in the sense that they want to deploy one Fission central to an organization, but being used by multiple business units or multiple consumers. While we have that support built into Fission, it is not very well documented. It is not very well explained from the end user's point of view. And that is something which will be coming in next few releases. And there are, again, many more exciting features. If you think there is something that you would love to see in Fission, please feel free to raise an issue on Fission GitHub repo. Cool. Now, what we'll do is I'm going to explain this real-world example, kind of very close to real-world example of a 6-function setup. So briefly, let me explain what happens. So in a typical like fleet scenario, let's say I have thousands of vehicles running across various locations all over country, and I have a sensor attached to each vehicle, and that sensor is sending data to me every, let's say, 10 seconds, for example. To simulate that, we have written a function called producer function. We are not actually getting it from vehicles, but we are just simulating that and producing a message every configurable window, whether it is 5 minutes or 1 minute or whatever. And that function basically drops the message into Kafka message queue. From Kafka message queue, as soon as you drop, a trigger gets triggered from Fission, and it invokes a consumer function. And this consumer function basically consumes this message and puts the process message into a Redis list, basically. And then there are a bunch of functions which are not necessarily reading this always. But if a user goes to a UI and says, give me a dashboard of all the function or all of my fleet information, it basically uses these 4 functions to fetch data from Redis and display in a very nice visual UI. So we'll deploy this. I'll show you 2 key things. First of all, how it gets built inside the Fission cluster, and then secondly, I'll show you that UI which I was talking about earlier. Cool. So this again is on the GitHub. You can go to Fission Kafka example in the Fission repo, and you'll see the code and everything, like how to create this from scratch. But let me just apply it right now here. So for the purpose of this demo, what I have already done is I have already deployed Kafka and Redis. So we have Redis namespace, there is Redis there, and Kafka namespace, Kafka is also there, just to save time. And now I'm in the Fission Kafka sample directory. So I have 3 different repositories: the consumer, the producer, and web. So the idea is this producer function is in the 0.1 producer package. And then all these functions are actually built from the same binary. So I'm having same Java jar file, but different entry points to the same one. And the web function, the dashboard, is actually a Python and HTML combined together. And then has specs directory, which actually has a definition of functions and environments and stuff like that. So let's run Fission spec validate quickly and see what we got in the specs. We have a bunch of warnings because this was built with a slightly older version of Fission. So we got 9 functions, 2 environments, 3 packages, 1 HTTP trigger, 1 message to trigger, and 3 archive upload spec, which is nothing but 2 jar files and 1 package for the UI package, right? Let's go ahead and apply this. I hope my cluster is big enough to handle all this together. Let me see if it is not, and if we can scale it up actually. All right, that looks good. So it has uploaded 2 archives, and we can actually see that on the packages, we should see 2 new Java build packages. I don't know why it is. Oh, the same problem as before, maybe, because now we are uploading Java functions. Right. So Java builder is still spinning up, and that's why it tried to build even before this came up, and that's why it failed. So let's wait for a minute for this to come up, and then we'll kick off the build again. Right, it is running now. So what I'm going to do is that kicks off one build. I'm also going to kick off the other build. Right, both of them are running. We can also look at the functions. Now, as you can see, as compared to the previous Hello and Hello.js, now we have a bunch of functions. So we got the count, data, and flush, cascade, and fuel average functions, which are of type new deploy. So earlier we used PoolManager, but now we are using new deployment executor because I want them to respond, super fast. I don't want any delay in between my calling a function and getting a response. And I have set a min scale and max scale on these functions. So now this is a feature that is not available on PoolManager, whereas it is available on the new deployment executor. And you can also have a HPA, the horizontal pod autoscaler. And you can say if the CPU of one pod starts crossing beyond 70%, spin up another pod, and so on and so forth. So this is auto scalable technically. And then we got IoT Web, which is a front end function, again new deploy type, and same with IoT Stats. And then there is KC, which is Kafka Consumer, and KP, which is Kafka Producer, and then Speed Average, which is another just statistics function. So as you can see, most of the functions I have a new deploy, and I have set the scale of 1 for minimum for almost everybody. But for some of them, I have set it to 2. Some of them I have set it to 10. I have also set a CPU and resource limits in terms of a minimum and max CPU. And then you can see the target CPU. So if any of these pods start crossing beyond 80%, they will make from 1 to 2. The scaling will happen automatically. And for the Kafka Consumer and Producer, if it starts crossing beyond 70% CPU, it will scale out from 1 to 2 to 3 and so on and so forth. We'll again have a quick demo of that once the build succeeds. All right, it is still running. I just want to show one more thing quickly. So since this build is still running, you can actually go and check the status here. Once the build actually finishes, you can see that the build is successful and the log is attached in the build logs. We don't have right now streaming log support, but the build logs is there. So we'll wait for this to finish, and I'll quickly finish a few more slides and then we'll come back. All right, so now if you want to start contributing to Fission as an engineer, you can start off with the contributing docs in the documentation. Please feel free to ask questions on Slack. You can find the Slack link on the Fission GitHub repo. And we are a very friendly community of people who are contributing, and we can help you get up to speed on this technology stack, so to speak. We also have bi-monthly meetings at 9:30 p.m. On Thursdays. I didn't mention the time here. I'll just, but you can also check out on this bit.ly link. There's a public documentation that we maintain where every meeting is kind of scheduled and the dates and links are available. So the next few meetings are on 2nd of July, 16th of July, and 30th of July. And if you want to start anything around cloud native or Kubernetes engineering development, I think this is a great book. If you haven't developed or written any operator or controller in Kubernetes world, this is the book I would start with, really. And I also want to mention another project that we have open source. It's called BotCube. So BotCube is an open source project to enable Slack kind of chat interface on Kubernetes cluster. So you can talk to your Kubernetes cluster using Slack or Mattermost or Microsoft Teams or Discord or a bunch of other apps, and it does a bunch of things apart from just being able to fire commands to Kubernetes cluster. It gives you notifications of critical events and stuff like that. And on BotCube, we have a webinar coming up next Thursday, 10:30 p.m. IST, as part of the Cloud Native Computing Foundation webinars. So this webinar will be live on 10:30 p.m. next Thursday, 25th of June. But a recording will also be available after that, and you're welcome to join either live webinar or join it, watch it later on the recording. Now let's go back and see, are we still seeing the build running? It's still running. In the meantime, what we can do is
Vishal, can we take up a few questions meanwhile?
Yeah, absolutely.
So I've got a question from Kaival here. He's asking, does KEDA scale the pool, cluster capacity, or replicas of the invocation?
So KEDA only scales the replicas of the invocation. It doesn't scale the pool of the cluster. The right way to scale the pool of the cluster is either use your cloud provider's ASG, auto-scaling group, or there's a project called Cluster Autoscaler, which is actually meant for scaling out your node pools.
Cool. And Vishal, I have a few questions. So, the current runtime that Fission supports, is it only Node.js and Go, or can we use anything else as well?
Oh, that's a great question. Actually, we have a bunch of them. So if you go and look at the environments in the Fission repository, we got .NET, Go, JVM, Node, Perl, PHP, Python, Ruby. And we also have a binary environment, which means you can execute any binary. It can be a shell script, it can be a Go binary. And we also have a TensorFlow serving environment, which allows you to just do the serving part of it, not the model or training part of it.
Okay. And what are the current limitations of Fission? So for example, if I'm pitching something to a customer, and if you're comparing this to other, vendor-based serverless frameworks like Lambda or Azure Functions or Google Functions, how do you compare? Like, what are the limitations that you're seeing in Fission right now?
Yeah, that's a pretty good question. At the same time, I would say a very broad question.
Okay.
I would say like there are definitely limitations. I'm not denying that, and I don't have a good like list of things that I have top of my head. Uh,
No, for an example, I'll give you in what context I'm asking. So, for example, when I'm talking about somebody to have a solution built around Lambda functions, there are certain limitations in terms of memory or in terms of overall runtime
sure,
or the time interval in which we need to execute that function. Right? Those are the limitations when you talk about Lambda. Now, in
right.
that context, what do you see where Fission? See, one thing that I understand is when you deploy something on Kubernetes, you are augmenting your resource requirements because Kubernetes itself is going to handle all those aspects, right? As you mentioned that, when you're reaching to certain capacity based on your configurations that you've set up for your pod, it's going to
Mhm.
increase or decrease the resources that are required, correct?
Right.
So other than that, what do you think, where you think, Fission, we are still working on certain features or
Sure.
some things that are limitations per se
Right.
right now.
So let me probably start the other way around, right? Like bunch of customers and users that we have seen that come to Fission, a couple of their reasons, right? So earlier, Lambda had a timeout limitation of I believe 5 minutes. Nowadays, probably 15 minutes or more. That is
Yes,
one
it's
thing.
15 minutes.
Yeah. So a lot of people who want to do more than that, like more than 15 minutes, is definitely one factor that Fission is like a great choice. Secondly, we have one customer. It's a telecom company. They actually have a lot of customers on-prem, and of course, on-prem you don't have anything else, or you can't technically run Lambda. So Fission is a great choice again for them. In terms of limitations, I would say uh, like the building part is kind of good, but I'm looking at a little more optimizations there. Maybe something like Canico might make the build a little more optimized. It is not exactly optimized right now. The other kind of request, and this is more of a limitation again, is a lot of people ask us to support Docker containers instead of, because some people want to upload Java or any code base.
Correct.
Some people want to say, I just want to throw a Docker container, and it should just work at that basically. So there are some fundamental changes we have to do to support Docker, and that is, I would say, probably one of the biggest limitations I think of it, personally.
Okay.
Mhm.
And okay, I think it's the packaging is done, right? Let's go back to the
Yeah,
demo.
right. So as you can see, the kind of build succeeded for both the functions, the KC and the KP. And what I'm going to do here is I'm going to first of all tail the logs of the KP pod so that you can actually see what is happening, and then we'll invoke the function. So so in the second half of my window on the bottom there is logs, and now I'm going to invoke the function uh, KP at the top. So what this is going to do is, going back to our diagram, we are basically calling the producer function, which is kind of emulating producing messages and putting into Kafka. All right, so let's do that. And as you can see, a bunch of Kafka messages have been produced, and this goes into Kafka queue. And now, without me calling the KC function, the consumer function is going to get triggered automatically because I have wired it up that way. So what we'll do is we'll get the list of consumer pods and look at the logs of those. It still hasn't arrived. I hope my Kafka is up and running. Oh, actually, there is a small problem I noticed. I should have witnessed this before. I actually did a fresh installation of Fission today afternoon, and I did not enable the Kafka integration, so to speak, inside the Fission installation. Let me see if there is a quick and dirty way of doing that, uh, but that still might take a little bit of time actually. How are you doing on time?
Vishal, we are about to close to our 1 hour.
Got it, got
1 hour
it.
time.
So then I think what
But
I'll
it's
do is,
okay.
yeah, this demo is again on the Kafka sample website, and this is what the dashboard looks like typically. Like it shows you various messages coming from the consumer side and going to producer side, and then it gives you an average stat of the truck distribution and the truck speed distribution. We can do it another time. It was just my bad that I didn't set it up, that way.
No
But
problem.
that's the, I would say, tail end of our talk for today. There are more questions. We can take that up.
Sure. So I have one question coming in from Selva, but I
Mhm.
think so. Question is, can you give some insights on CADA? So I believe it is going to call for another session if I'm not wrong.
Yeah, totally. You can do another session on KEDA. That'll be super helpful. But you can go and check out the KEDA website. It's pretty neat and self-explanatory. And I think my talk that I did yesterday on Cloud Community Days covers that in super depth, actually. So I'll post that link in the, I don't know if I can post that link in the comments on the
Yeah, I'll
YouTube.
do that. I'll do that. Fine. So I think Vishal, that was really an insightful session.
Mhm.
Before we move on, I have one question.
Yeah.
So you mentioned about sidecars, right?
Mhm.
And on other aspect, you were saying that, for example, if you're using Node.js or anything like that, it does create the packages as well, right? So, in Lambda, we have a concept of this layers where I
Mhm.
could have a pre-compiled libraries that I want to use, and then I
Mhm.
can go and share those libraries across my functions, right?
Sure.
The sidecar function that you were mentioning earlier, can it be
Mhm.
used in this way that I can use that as pre-compiled libraries across all my functions, and it basically helps me to you know gain better speed and lesser cost.
Yeah, that's a great idea. I think Sidecar allows you to mount volumes on the primary pod, and if you can do that, yes, I think you can technically use that layer or libraries or whatever from Sidecar as well.
Okay, good to hear that. Fine. I have few more, but I'm gonna try using Fission, and then I'm gonna reach out to you again.
Yeah. If you have anything that is probably of interest to everybody else, we can still take it. But yeah, I leave it that to you. Okay.
No problem. So, Vishal, I think I had a good insights on how to start with Fission, and I
Hmm.
am sure the community is also benefited by it. And
Sure.
thanks a lot for taking time out and helping us to understand this.
Hmm.
And why don't you summarize? Like, why don't you tell people in Fission what kind of a contribution you are looking at? I know it's an open source project, and you always need people to help you out to push for next releases, right? So,
Right,
what
right.
are the different things that you are looking at? To summarize this session, I think that would be a good point.
Sure. So I think especially for new contributors, who are new to either Kubernetes development, we have kind of marked a lot of issues as first good issues. So those are like the issues that are good for new contributors, and those are like great way to start, and also understand the project, without getting overwhelmed, because sometimes it can be overwhelming. There are too many things to track and learn, especially given the complexity of Kubernetes and the underlying, programming and stuff like that. So I would say some of these features are great. Some of these issues are great start for anybody contributing new. And definitely, if anybody has experience with Golang, that's a good starting point. And of course, you need to understand a little bit of Kubernetes API beyond the basic contributions. So I think in terms of features, we are looking definitely for more environments. For example, if you have TensorFlow serving, we can potentially have more. Also, once we have this SCADA integration in place, we are actually going to start with like 2 to 3 integrations, but rest of the integrations can be developed by community, and we'll raise new issues for that. And those are relatively like very standalone pieces of integration. You don't need to understand all of Fission to develop those. So those will be very welcome as well. And I would say one other thing which we talk about in Kubernetes community as well is not all contribution is code. Sometimes documentation or trying out, raising bugs, asking questions on Slack is contribution as well. So feel free to read through docs. If you find anything obvious, or if you find something new that is not documented, feel free to raise a peer on documentation repositories as well, and that is always welcome, of course.
Okay. Thanks a lot, Vishal, again. I think, and thanks a lot for everybody to tune in for today's talk. And from today onwards, actually, Vishal, today was supposed to be Ahmedabad Serverless Days. So
Sure.
I marked this day so
Got it.
that by the time we are having our next our serverless days, till then we are doing this 1 hour a week
Sure.
serverless meetups.
Right.
Fine. Okay. Have a last question coming in from Kaivalya. Is the
Sure.
TensorFlow serving
Shared.
shared with the KF serving project?
I'm not super familiar with the details of the TensorFlow environment because actually myself didn't develop it or use it. I do believe it is not shared with KF serving project. It's a separate like runtime build separately. But I can confirm that question, Kavali, later if you ping me on Slack or something.
Cool. No worries. So thanks a lot, Vishal. I think it's time for us to conclude. Thanks again for the time, and thanks a lot everybody to tune in. Bye bye.
So thanks for hosting me, Ankit. Really enjoyed it.
Pleasure. Okay. Bye.